The chemical industry comprises the companies that produce industrial chemicals. Central to the modern world economy, it converts raw materials, oil, natural gas, air, water, metals, and minerals, into more than 70,000 different products. The plastics industry contains some overlap, as most chemical companies produce plastic as well as other chemicals. History. Although chemicals were made and used throughout history, the birth of the heavy chemical industry, production of chemicals in large quantities for a variety of uses, coincided with the beginnings of the Industrial Revolution in general. Industrial Revolution. One of the first chemicals to be produced in large amounts through industrial process was sulfuric acid. In 1736, the pharmacist Joshua Ward developed a process for its production that involved heating saltpeter, allowing the sulfur to oxidize and combine with water. It was the first practical production of sulfuric acid on a large scale. John Roebuck and Samuel Garbett were the first to establish a large-scale factory in Prestonpans, Scotland, in 1749, which used leaden condensing chambers for the manufacture of sulfuric acid. In the early 18th century, cloth was bleached by treating it with stale urine or sour milk and exposing it to sunlight for long periods of time, which created a severe bottleneck in production. Sulfuric acid began to be used as a more efficient agent as well as lime by the middle of the century. But it was the discovery of bleaching powder by Charles Tennant that spurred the creation of the first great chemical industrial enterprise. His powder was made by reacting chlorine with dry slaked lime and proved to be a cheap and successful product. He opened a factory in St. Rollox, north of Glasgow, and production went from just 52 tons in 1799 to almost 10,000 tons just 5 years later. Soda ash was used since ancient times in the production of glass, textile, soap, and paper, and the source of the potash had traditionally been wood ashes in Western Europe. By the 18th century, this source was becoming uneconomical due to deforestation, and the French Academy of Sciences offered a prize of 2,400 livres for a method to produce alkali from sea salt, sodium chloride. The Leblanc process was patented in 1791 by Nicolas Leblanc, who then built a Leblanc plant at St. Denis. He was denied his prize money because of the French Revolution. However, it was in Britain that the Leblanc process really took off. William Losh built the first soda works in Britain at the Losh, Wilson and Bell Works on the River Tyne in 1816. But it remained on a small scale due to large tariffs on salt production until 1824. When these tariffs were repealed, the British soda industry was able to rapidly expand. James Muspratt's chemical works in Liverpool and Charles Tennant's complex near Glasgow became the largest chemical production centres anywhere. By the 1870s, the British soda output of 200,000 tons annually exceeded that of all other nations in the world combined. These huge factories began to produce a greater diversity of chemicals as the Industrial Revolution matured. Originally, large quantities of alkaline waste were vented into the environment from the production of soda, provoking one of the first pieces of environmental legislation to be passed in 1863. This provided for close inspection of the factories and imposed heavy fines on those exceeding the limits on pollution. Methods were soon devised to make useful byproducts from the alkali. The Solvay process was developed by the Belgian industrial chemist Ernest Solvay in 1861. In 1864, Solvay and his brother Alfred constructed a plant in the Belgian town of Charleroi, and in 1874, they expanded into a larger plant in Nancy, France. The new process proved more economical and less polluting than the Leblanc method, and its use spread. In the same year, Ludwig Mond visited Solvay to acquire the rights to use his process, and he and John Brunner formed the firm of Brunner, Mond & Co., and built his Solvay plant at Winnington, England. Mond was instrumental in making the Solvay process a commercial success. He made several refinements between 1873 and 1880 that removed byproducts that could slow or halt the mass production of sodium carbonate through use of the process. Expansion and maturation. The late 19th century saw an explosion in both the quantity of production and the variety of chemicals that were manufactured. Large chemical industries also took shape in Germany and later in the United States. Production of artificial manufactured fertilizer for agriculture was pioneered by Sir John Laws at his purpose-built Rothamsted research facility. In the 1840s he established large works near London for the manufacture of superphosphate of lime. Processes for the vulcanization of rubber were patented by Charles Goodyear in the United States and Thomas Hancock in England in the 1840s. The first synthetic dye was discovered by William Henry Perkin in London. He partly transformed aniline into a crude mixture which, when extracted with alcohol, produced a substance with an intense purple color. He also developed the first synthetic perfumes. However, it was German industry that quickly began to dominate the field of synthetic dyes. The three major firms BASF, Bayer and Hoechst produced several hundred different dyes, and by 1913, the German industry produced almost 90% of the world's supply of dyestuffs and sold about 80% of their production abroad. In the United States, Herbert Henry Dow's use of electrochemistry to produce chemicals from brine was a commercial success that helped to promote the country's chemical industry. The petrochemical industry can be traced back to the oil works of James Young in Scotland and Abraham Pinio Gesner in Canada. The first plastic was invented by Alexander Parkes, an English metallurgist. In 1856, he patented Parksine, a celluloid based on nitrocellulose treated with a variety of solvents. This material, exhibited at the 1862 London International Exhibition, anticipated many of the modern aesthetic and utility uses of plastics. The industrial production of soap from vegetable oils was started by William Lever and his brother James in 1885 in Lancashire based on a modern chemical process invented by William Huff Watson that used glycerin and vegetable oils. By the 1920s, chemical firms consolidated into large conglomerates. IG Farben in Germany, Rhône Poulenc in France and Imperial Chemical Industries in Britain. DuPont became a major chemicals firm in the early 20th century in America. Currently chemical production is a high-tech industry, where the competitiveness is more based on capacity and investment on research and development than the labor cost. Products, polymers and plastics, especially polyethylene, polypropylene, polyvinyl chloride, polyethylene terephthalate, polystyrene and polycarbonate comprise about 80% of the industry's output worldwide. These materials are often converted to fluoropolymer tubing products and used by the industry to transport highly corrosive materials. Chemicals are used in a lot of different consumer goods, but they are also used in a lot of different other sectors, including agriculture, manufacturing, construction, and service industries. Major industrial customers include rubber and plastic products, textiles, apparel, petroleum refining, pulp and paper, and primary metals. Chemicals are nearly a $3 trillion global enterprise, and the EU and US chemical companies are the world's largest producers. Sales of the chemical business can be divided into a few broad categories, including basic chemicals, about 35 to 37% of the dollar output, life sciences, 30%, specialty chemicals, 20 to 25%, and consumer products, about 10%. Basic chemicals and commodity chemicals to polymers and specialty chemicals. Basic chemicals, or commodity chemicals, are a broad chemical category including polymers, bulk petrochemicals and intermediates, other derivatives and basic industrials, inorganic chemicals, and fertilizers. Typical growth rates for basic chemicals are about 0.5 to 0.7 times GDP. Product prices are generally less than 50 cents per pound. Polymers, the largest revenue segment at about 33% of the basic chemicals dollar value, includes all categories of plastics and man-made fibers. The major markets for plastics are packaging, followed by home construction, containers, appliances, pipe, transportation, toys, and games. The largest volume polymer product, polyethylene, P, is used mainly in packaging films and other markets such as milk bottles, containers, and pipe. Polyvinyl chloride, PVC, another large volume product, is principally used to make piping for construction markets as well as siding and, to a much smaller extent, transportation and packaging materials. Polypropylene, PP, similar in volume to PVC, is used in markets ranging from packaging, appliances, and containers to clothing and carpeting. Polystyrene, PS, another large volume plastic, is used principally for appliances and packaging as well as toys and recreation. The leading man-made fibers include polyester, nylon, polypropylene, and acrylics, with applications including apparel, home furnishings, and other industrial and consumer use. The principal raw materials for polymers are bulk petrochemicals. Chemicals in the bulk petrochemicals and intermediates are primarily made from liquefied petroleum, gas, LPG, natural gas, and crude oil. Their sales volume is close to 30% of overall basic chemicals. Typical large volume products include ethylene, propylene, benzene, toluene, xylenes, methanol, vinyl chloride monomer, VCM, styrene, butadiene, and ethylene oxide. These basic commodity chemicals are the starting materials used to manufacture many polymers and other more complex organic chemicals, particularly those that are made for use in the specialty chemicals category. See below. Other derivatives and basic industrials include synthetic rubber, surfactants, dyes and pigments, turpentine, resins, carbon black, explosives, and rubber products, and contribute about 20% of the basic chemicals' external sales. Inorganic chemicals, about 12% of the revenue output, make up the oldest of the chemical categories. Products include salt, chlorine, caustic soda, soda ash, acids, such as nitric acid, phosphoric acid, and sulfuric acid, titanium dioxide, and hydrogen peroxide. Fertilizers are the smallest category, about 6%, and include phosphates, ammonia, and potash chemicals. Life sciences, about 30% of the dollar output of the chemistry business, include differentiated chemical and biological substances, pharmaceuticals, diagnostics, animal health products, vitamins, and pesticides. While much smaller in volume than other chemical sectors, their products tend to have very high prices, over $10 per pound, growth rates of 1.5 to 6 times GDP, and research and development spending at 15 to 25% of sales. Life science products are usually produced with very high specifications and are closely scrutinized by government agencies such as the Food and Drug Administration. Pesticides, also called crop protection chemicals, are about 10% of this category and include herbicides, insecticides, and fungicides. Specialty chemicals. Specialty chemicals are a category of relatively high-valued, rapidly growing chemicals with diverse end product markets. Typical growth rates are 1 to 3 times GDP with prices over $1 per pound. They are generally characterized by their innovative aspects. Products are sold for what they can do rather than for what chemicals they contain. Products include electronic chemicals, industrial gases, adhesives and sealants, as well as coatings, industrial and institutional cleaning chemicals, in catalysts. In 2012, excluding fine chemicals, the $546 billion global specialty chemical market was 33% paints, coating and surface treatments, 27% advanced polymer, 14% adhesives and sealants, 13% additives and 13% pigments and inks. Specialty chemicals are sold as effective performance chemicals. Sometimes they are mixtures of formulations. Unlike fine chemicals, which are almost always single-molecule products. Consumer products. Consumer products include direct product sale of chemicals such as soaps, detergents, and cosmetics. Typical growth rates are 0.8 to 1.0 times GDP. Consumers rarely if ever come into contact with basic chemicals, but polymers and specialty chemicals are the materials that they will encounter everywhere in their everyday lives, such as in plastics, cleaning materials, cosmetics, paints and coatings, electronic gadgets, automobiles and the materials used to construct their homes. These specialty products are marketed by chemical companies to the downstream manufacturing industries as pesticides, specialty polymers, electronic chemicals, surfactants, construction chemicals, industrial cleaners, flavors and fragrances, specialty coatings, printing inks, water-soluble polymers, food additives, paper chemicals, oil field chemicals, plastic adhesives, adhesives and sealants, cosmetic chemicals, water management chemicals, catalysts, textile chemicals. Chemical companies rarely supply these products directly to the consumer. Every year, the American Chemistry Council tabulates the U.S. production volume of the top 100 basic chemicals. In 2000, the aggregate production volume of the top 100 chemicals totaled 502 million tons, up from 397 million tons in 1990. Inorganic chemicals tend to be the largest volume, though much smaller in dollar revenue terms due to the low prices. The top 11 of the 100 chemicals in 2000 were sulfuric acid, 44 million tons, nitrogen, 34, ethylene, 28, oxygen, 27, lime, 22, ammonia, 17, propylene, 16, polyethylene, 15, chlorine, 13, phosphoric acid, 13, and diammonium phosphates, 12. Companies. The largest chemical producers today are global companies with international operations and plants in numerous countries. A list of the top 25 chemical companies by chemical sales in 2015 appears below. Note: chemical sales represent only a portion of total sales for some companies. Top chemical companies by chemical sales in 2015. Technology. From the perspective of chemical engineers, the chemical industry involves the use of chemical processes such as chemical reactions and refining methods to produce a wide variety of solid, liquid, and gaseous materials. Most of these products serve to manufacture other items, although a smaller number go directly to consumers. Solvents, pesticides, lye, washing soda, and Portland cement provide a few examples of product used by consumers. The industry includes manufacturers of inorganic and organic industrial chemicals, ceramic products, petrochemicals, agrochemicals, polymers and rubber, elastomers, oleochemicals, oils, fats, and waxes, explosives, fragrances and flavors. Examples of these products are shown in the table below. Although the pharmaceutical industry is often considered a chemical industry, it has many different characteristics that puts it in a separate category. Other closely related industries include petroleum, glass, paint, ink, sealant, adhesive, and food processing manufacturers. Chemical processes such as chemical reactions operate in chemical plants to form new substances in various types of reaction vessels. In many cases the reactions take place in special corrosion-resistant equipment at elevated temperatures and pressures with the use of catalysts. The products of these reactions are separated using a variety of techniques including distillation, especially fractional distillation, precipitation, crystallization, adsorption, filtration, sublimation, and drying. The processes and products are usually tested during and after manufacture by dedicated instruments and on-site quality control laboratories to ensure safe operation and to assure that the product will meet required specifications. More organizations within the industry are implementing chemical compliance software to maintain quality products and manufacturing standards. The products are packaged and delivered by many methods, including pipelines, tank cars, and tank trucks, for both solids and liquids, cylinders, drums, bottles, and boxes. Chemical companies often have a research and development laboratory for developing and testing products and processes. These facilities may include pilot plants, and such research facilities may be located at a site separate from the production plant. World chemical production. The scale of chemical manufacturing tends to be organized from largest in volume, petrochemicals and commodity chemicals, to specialty chemicals, and the smallest, fine chemicals. The petrochemical and commodity chemical manufacturing units are on the whole single product, continuous processing plants. Not all petrochemical or commodity chemical materials are made in one single location, but groups of related materials often are to induce industrial symbiosis as well as material energy and utility efficiency and other economies of scale. Those chemicals made on the largest of scales are made in a few manufacturing locations around the world. For example, in Texas and Louisiana along the Gulf Coast of the United States, on Teesside in the northeast of England in the United Kingdom, and in Rotterdam in the Netherlands. The large-scale manufacturing locations often have clusters of manufacturing units that share utilities and large-scale infrastructure such as power stations, port facilities, road and rail terminals. To demonstrate the clustering and integration mentioned above, some 50% of the United Kingdom's petrochemical and commodity chemicals are produced by the northeast of England process industry cluster on Teesside. Specialty chemical and fine chemical manufacturing are mostly made in discrete batch processes. These manufacturers are often found in similar locations, but in many cases they are to be found in multi-sector business parks, continents and countries. In the U.S., there are 170 major chemical companies. They operate internationally with more than 2,800 facilities outside the U.S., and 1,700 foreign subsidiaries or affiliates operating The U.S. chemical output is $750 billion a year. The U.S. industry records large trade surpluses and employs more than 1 million people in the United States alone. The chemical industry is also the second largest consumer of energy in manufacturing and spends over $5 billion annually on pollution abatement. In Europe, the chemical, plastics and rubber sectors are among the largest industrial sectors. Together they generate about 3.2 million jobs in more than 60,000 companies. Since 2000, the chemical sector alone has represented 2/3 of the entire manufacturing trade surplus of the EU. In 2012, the chemical sector accounted for 12% of the EU manufacturing industry's added value. Europe remains world's biggest chemical trading region with 43% of the world's exports and 37% of the world's imports. Although the latest data shows that Asia is catching up with 34% of the exports and 37% of imports. Even so, Europe still has a trading surplus with all regions of the world except Japan and China, where in 2011 there was a chemical trade balance. Europe's trade surplus with the rest of the world today amounts to €41.7 billion. Over the 20 years between 1991 and 2011, the European chemical industry saw its sales increase €295 billion to €539 billion, a picture of constant growth. Despite this, the European industry's share of the world chemical market has fallen from 36% to 20%. This has resulted from the huge increased production and sales in the emerging markets like India and China. The data suggests that 95% of this impact is from China alone. In 2012, the data from the European Chemical Industry Council (CEFIC) shows that 5 European countries account for 71% of the EU's chemicals sales. These are Germany, France, United Kingdom, Italy and the Netherlands. The chemical industry has shown rapid growth for more than 50 years. The fastest growing areas have involved the manufacture of synthetic organic polymers used as plastics, fibers and elastomers. Historically and presently, the chemical industry has been concentrated in 3 areas of the world: Western Europe, North America and Japan. The triad. The European community remains the largest producer area, followed by the US and Japan. The traditional dominance of chemical production by the triad countries is being challenged by changes in feedstock availability and price, labor cost, energy cost, differential rates of economic growth and environmental pressures. Instrumental in the changing structure of the global chemical industry has been the growth in China, India, Korea, the Middle East, Southeast Asia, Nigeria, and Brazil. Just as companies emerge as the main producers of the chemical industry, we can also look on a more global scale to how industrialized countries rank with regards to the billions of dollars worth of production a country or region could export. Though the business of chemistry is worldwide in scope, the bulk of the world's $3.7 trillion chemical output is accounted for by only a handful of industrialized nations. The United States alone produced $689 billion, 18.6% of the total world chemical output in 2008. See also: chemical engineering, chemical leasing, pharmaceutical industry, industrial gas, prices of elements and their compounds, responsible care, fine chemicals, specialty chemicals, commodity chemicals, petrochemicals, Northeast of England process industry cluster, NEPIC. World of Chemicals is a chemical portal, a networking community for the chemical fraternity. http://www.worldofchemicals.com Com. Fred Afdalian, A History of the International Chemical Industry. University of Pennsylvania Press. 1991. Online version. E. N. Brandt. Growth Company. Dow Chemicals First Century. Michigan State University Press. XXII plus 650 pp. Appendices. Select bibliography and index. ISBN 0-87013-4264. Online review. Alfred D. Chandler. Shaping the Industrial Century. The Remarkable Story of the Evolution of the Modern Chemical and Pharmaceutical Industries. Harvard University Press. 2005. 366 pp. ISBN 0-674-01720-X. Chapters 3-6 deal with DuPont, Dow Chemicals, Monsanto, American Cyanamide, Union Carbide, and Allied in U.S. and European chemical producers, Bayer, Farben, and ICI. Michael McCoy, al. Facts and Figures of the Chemical Industry. Chemical and Engineering News. 84. 28. July 10, 2006. pp. 35-72. Shreve, R. Norris, and Joseph A. Brink, Jr. The Chemical Process Industries. 4th ed. New York. McGraw-Hill. 1977. Wojtinski, W. S. and E. S. Wojtinski. World Population and Production Trends and Outlooks. 1953. pp. 1176-1205. With many tables and maps on the worldwide chemical industry in 1950. Chemical Refinery Resources http www.cccgroup.com. Chemicals, Solutions, Industrial 1.